Hello, and welcome to tonight's Space Sleep story. If you appreciate what we do here, please like or subscribe for future relaxing nighttime space journeys. Tonight, we drift through the asteroid belt, that mysterious region between Mars and Jupiter. But forget everything Hollywood has taught you. The reality is far more beautiful than fiction. So settle into your most comfortable position. Close your eyes and prepare to float through the peaceful river of worlds. Before we begin, let us prepare your body and mind with gentle breathing. Take a slow, deep breath with me now. Inhale gently for 4 counts. Hold the peace within you. Now exhale slowly for 6 counts. Feel your body releasing into stillness, releasing the tension of the day. With each breath, you sink deeper into comfort, floating like an asteroid in space, peaceful and timeless. Another gentle breath as we continue our preparation. This time, notice how your chest rises and falls, like the gentle tumbling of an ancient stone in the vastness. Breathe in slowly, filling your lungs completely. Hold this peaceful moment. Feel the stress leaving your body with each exhale. Let my voice be your guide through the emptiness. With each breath, you release a little more into relaxation, drifting further from the day behind you. We begin our journey at 2.7 astronomical units from the Sun. 1 AU is the distance from Earth to the Sun, about 150 million kilometers. Here, we're 400 million kilometers from home, floating between the orbits of Mars and Jupiter. Hollywood would have you believe this is a dangerous maze of tumbling rocks, dense asteroid fields requiring constant evasive maneuvers. But look around you. Nothing but darkness and distant stars. The truth is more beautiful than the fiction. The asteroid belt extends from 2.2 to 3.2 AU from the Sun. A vast ring, 150 million kilometers wide, billions of kilometers in volume. And yes, it contains millions of asteroids, perhaps 1.1 to 1.9 million asteroids larger than 1 kilometer across. But here's what Hollywood never tells you. The average distance between those kilometer-sized asteroids is 600,000 kilometers. That's 1.5 times the distance from Earth to the Moon. Mostly, space is empty here. Beautifully, peacefully empty. If you gathered every asteroid in the belt and pressed them together into a single body, you'd create a world about 1,500 kilometers in diameter. That's only 3 to 4% of the Moon's mass. The asteroid belt didn't fail to become a planet. It never had enough material to begin with. Jupiter's gravity prevented that material from ever accumulating, stirring the orbits, keeping collision speeds too high for gentle accretion. What remains are ancient witnesses to the solar system's formation, peaceful fragments orbiting in the darkness. NASA has sent spacecraft through this belt many times. Pioneer 10 in 1972 was the first. Then Pioneer 11, Voyagers 1 and 2, Galileo, Cassini, New Horizons. Not one required collision avoidance maneuvers. Not once did they need to dodge tumbling rocks or navigate through dense fields. They simply drifted through, just as we're doing now. The belt is so sparse that crossing it at a random trajectory gives you essentially zero probability of hitting anything. Safe passage through ancient emptiness. As we float here in the peaceful darkness, let us encounter our first asteroid. It appears ahead, a small grey world about 20 kilometers across. It tumbles slowly, rotating every 8 hours, its surface pocked with craters from 4.6 billion years of impacts. Surface temperature here is approximately -85 degrees Celsius. Cold, but not as cold as the outer solar system. We drift closer. Minutes pass. It takes time to approach at our gentle pace. No rush. Just peaceful observation of an ancient stone. This is an S-type asteroid, one of the silicate or stony types that make up about 17% of the belt population. Its surface is grey rock, iron and magnesium silicates, slightly processed by ancient heating. As we pass within a few kilometers, you can see individual boulders on the surface, some as large as houses. The regolith, a fine dust layer, covers everything, created by billions of years of micrometeorite impacts gardening the surface. And then we drift past. The asteroid recedes behind us, shrinking back to a point of light. Once again, we're surrounded by emptiness. Hours might pass before we encounter another asteroid. In that time, we simply float, watching the distant stars, the faint glow of the sun. There's profound beauty in this emptiness. Space here isn't a void to be feared, but a peaceful expanse to be appreciated. The silence is complete. No sound travels through vacuum. Only the gentle drift of your consciousness, your breathing slowing, your body settling deeper into rest. You're safe here, in the vastness between worlds. Nothing rushing toward you, nothing demanding attention, just peaceful floating. On January 1st, 1801, on the very first night of the 19th century, an Italian astronomer named Giuseppe Piazzi discovered the first asteroid. He called it Ceres. Piazzi wrote in his journal, "The light was a little faint and of the colour of Jupiter, but similar to many others which generally are reckoned of the 8th magnitude. It has occurred to me several times that it might be something better than a fixed star. Something better than a fixed star." He was right. He'd discovered a new world, opening an entirely new field of astronomy. Within 6 years, 4 asteroids were known: Ceres, Pallas, Juno, and Vesta. Astronomers thought that was all there were. For 38 years, no new asteroids were found. From 1807 to 1845, astronomers assumed only 4 existed. Then, an amateur astronomer named Carl Ludwig Henke refused to give up searching. In 1845, he found the 5th asteroid, Asteroid. That discovery sparked renewed interest. By 1868, 100 asteroids were catalogued. Today, over 500,000 have been numbered and tracked. The belt revealed its true population slowly, patiently. Ahead in the distance, a much larger world appears. As we drift closer over many hours, it grows from a point to a disk. This is Ceres, the largest asteroid in the belt. At 946 kilometers in diameter, Ceres is massive enough that its own gravity has pulled it into a spherical shape. It was reclassified as a dwarf planet in 2006, joining Pluto in that category. Ceres contains approximately 30% of the total mass of the entire asteroid belt. One world holding merely a third of all the material in this vast region. As we approach, we see it's not just a dead rock. NASA's Dawn spacecraft orbited Ceres from 2015 to 2018. What it discovered surprised everyone. Bright spots appear on Ceres' surface, particularly in Ocata crater. These are salt deposits left behind when subsurface brines reached the surface and evaporated. Ceres may have a subsurface ocean of liquid water beneath its icy crust. Chris Russell, the Dawn mission principal investigator, said of the discovery, "We realized Ceres is geologically active now, not just an ancient relic." Even here, 400 million kilometers from the Sun, on a small world most people have never heard of, there might be liquid water. Ancient oceans hidden beneath stone. As we continue our drift, we encounter Vesta, the second largest asteroid. 525 kilometers in diameter, irregular in shape. Vesta is something extraordinary, a planetary embryo that never finished growing. It has a differentiated interior with an iron core, rocky mantle, and basaltic crust. This is what the inside of a forming planet looks like. If Jupiter hadn't disrupted the asteroid belt, Vesta might have continued accreting material and grown into a terrestrial world like Earth or Mars. Instead, it remains frozen in time, a snapshot of planetary formation, an embryo that never became. At Vesta's south pole lies an enormous impact crater called Rhea Silvia, 505 kilometers wide and 19 kilometers deep. It's one of the largest impact structures in the entire solar system. That collision was so violent, it sent fragments flying all the way to Earth. We have pieces of Vesta in our meteorite collections. Scientists call them HED meteorites, Howardites, Eucrites, and Diogenites. When you see those meteorites in a museum, you're looking at fragments blasted from Vesta's crust billions of years ago, traveled through space, and fallen to Earth. Ancient stones with incredible stories. Carol Raymond, Dawn's deputy principal investigator, described Vesta beautifully. Vesta is a time capsule from the violent first 10 million years of solar system history. We're looking at a preserved protoplanet, the embryo of what might have become an Earth-like world if Jupiter hadn't disrupted formation. Floating here, observing Vesta's scarred surface, we're witnessing deep time made visible. This world remembers the chaos of planetary birth, when hundreds of protoplanets collided and merged, building the terrestrial worlds we know today. Vesta survived that chaos, too small and too isolated to be swept up. It remains a monument to what might have been. The asteroids come in different types, each telling a different story about the solar system's formation. The most common are C-types, carbonaceous asteroids. They make up about 75% of the belt population. C-types are dark, almost black, with very low reflectivity. They're carbon-rich, chemically primitive, preserving material essentially unchanged since the solar nebula collapsed 4.6 billion years ago. These are samples of the primordial chemistry that built everything. C-types are concentrated in the outer belt, where cooler temperatures preserved volatile compounds. Some contain up to 10% water by mass, locked in hydrated minerals. Ancient ice hidden in stone. As we drift deeper into contemplation, consider what these carbonaceous asteroids might have delivered to early Earth. During the period called the Late Heavy Bombardment, about 4 billion years ago, Earth was struck by countless asteroids. If those asteroids were water-rich C-types, they could have delivered the water that now fills Earth's oceans. Planetary scientist Kathy Mant put it beautifully. If asteroids brought water to early Earth, then every ocean, every river, every cell in your body contains atoms that spent billions of years in an asteroid. You are partly made of asteroid material. The water in your body once drifted here in the darkness. Deep connection across billions of years. We drift onward through the belt, encountering different types of asteroids. M-type asteroids, metallic worlds composed primarily of iron and nickel. These have densities of 5.3 to 7.8 grams per cubic centimeter, denser than ordinary rock, bright and reflective. M-types are likely the exposed cores of protoplanets that differentiated, with heavy metals sinking to the center, then were shattered by impacts. We're seeing planetary interiors exposed. Metal that once was buried deep inside a forming world, now floating alone in darkness. Ancient catastrophes frozen in iron. Throughout the belt, there are asteroid families, clusters of asteroids with similar orbits and compositions. The Eos family, Flora family, Coronis family, Themis family. Each family represents an ancient collision. A large asteroid struck by an impactor, shattered into thousands of fragments. Those fragments still orbit near each other, millions or even billions of years later. Forensic evidence of violent events preserved in orbital mechanics. By studying family members today, we can reconstruct collision dynamics from the distant past. The belt remembers its history. The stones keep patient records. There are gaps in the belt, regions nearly empty of asteroids. These are called Kirkwood gaps. They occur at specific orbital distances where resonances with Jupiter create instability. An asteroid at the 3:1 resonance, for example, orbits 3 times for every 1 Jupiter orbit. It receives a gravitational tug from Jupiter at exactly the same point every 3 orbits. Over millions of years, those perturbations accumulate. The asteroid's orbit becomes unstable, and it's ejected to a different distance. Jupiter's gravity sculpts the belt, creating structure within the distribution. Empty zones carved by giant planet influence. In 1991, NASA's Galileo spacecraft became the first to fly close to an asteroid. It encountered 951 Gaspra on its way to Jupiter. Carolyn Porco, part of the Galileo imaging team, described the moment beautifully. "We went to photograph a star-like point of light in our telescopes and came away with a world. Every crater, every facet told a story spanning billions of years. That's the moment asteroids became places, not just points. A shift in understanding. These aren't abstract objects. They're worlds, each with unique geology, history, story. Places you could visit, walk upon, explore." Two years later, Galileo encountered asteroid 243 Ida and discovered something no one expected. Ida has a moon, a tiny asteroid only about 1.5 kilometers across, orbiting Ida. Scientists named it Dactyl. That discovery revolutionized understanding. Asteroids can have satellites. Weak gravity, but gravity nonetheless, enough to capture a companion or keep fragments from ancient collisions bound together. Since then, dozens of asteroid moons have been discovered. Even here in the sparse belt, worlds orbit worlds. Complexity within simplicity. In 2001, NASA's Near-Shoemaker spacecraft achieved something remarkable. It became the first spacecraft to land on an asteroid. The mission was designed only to orbit 433 Eros, a near-Earth asteroid. But as fuel ran low, mission controllers thought, why not try landing? The spacecraft wasn't designed for it. No landing legs, no cushioning systems. Yet it survived touchdown and transmitted data from the surface for 2 weeks. Joseph Faverka, the mission's principal investigator, said, "We never designed Near to land. It was a pure orbital mission. But that spacecraft survived touchdown and kept transmitting. Engineering brilliance and calculated risk-taking at its finest." Let us slow our journey now. Breathe with the vastness. Inhale slowly, filling your lungs with peace. Hold gently. Exhale, releasing into the emptiness. The asteroids drift at speeds of 17 to 25 kilometers per second, depending on their distance from the Sun. Orbital periods range from 3.5 years in the inner belt to 6 years or more in the outer regions. Your breath completes its cycle in seconds. Asteroids complete their cycles in years. Different timescales, but both are rhythms. Both are predictable. Both are peaceful. Most asteroids rotate in 6 to 12 hours. If you stood on one, day and night would cycle twice as fast as on Earth. Some spin much faster, completing rotations in just 2 or 3 hours. They're approaching breakup velocity. Spin faster and centrifugal force would overcome their weak gravity. The asteroid would fly apart. Others rotate slowly, taking days to complete one turn. Each has a unique tumbling pattern set by ancient collisions billions of years ago. Still spinning from impacts that happened before Earth had oceans, before life began. Ancient motion continuing through emptiness. In 2020, the Japanese spacecraft Hayabusa2 returned samples from the asteroid Ryugu. The sample capsule landed in the Australian desert in December. Makoto Yoshikawa, the mission manager, described opening the capsule. When we found black sand from Ryugu inside, 4.6 billion years old, never contaminated by Earth, several of us cried. We'd brought home a piece of the solar system's birth. Black sand older than Earth's oceans, older than the continents, preserved in the deep freeze of space. Now in laboratories, being studied grain by grain. Ancient chemistry revealing solar system origins. A year later, NASA's OSIRIS-REx mission returned samples from asteroid Bennu. Principal investigator Dante Loretta described what they learned about Bennu's surface. When the spacecraft's arm touched down, it sank about half a meter into the surface. Bennu's not solid rock. It's more like a ball pit filled with boulders. If you walked on it, you'd sink. This revolutionized understanding. Many asteroids aren't monolithic rocks, but rubble piles. Loose collections of fragments held together by weak gravity. Ancient collisions shattered protoplanets. Fragments slowly reaccumulated into rubble piles. The surface isn't solid ground, but mobile regolith. Both missions found water-bearing minerals in their samples. Both found organic molecules. Both found amino acids. The building blocks of life, preserved in asteroids. Similar material may have been delivered to early Earth through impacts. The chemistry necessary for life wasn't a purely terrestrial invention. It was common throughout the early solar system, Life may be an inevitable consequence of chemistry, not a miraculous accident. And the asteroid belt helped write that story. Water and organics delivered to a young planet. 4 billion years later, that planet wonders about its origins and finds answers in ancient stones. We drift deeper into the belt now, surrounded by darkness and stars. The emptiness is beautiful. Hollywood taught you to fear the asteroid belt, to see it as an obstacle, a danger. But floating here, you understand the truth. It's peaceful, vast, mostly empty space. The asteroids we encounter are rare gifts, brief glimpses of ancient worlds, then back to the emptiness. And the emptiness itself is meaningful. It teaches patience. It teaches appreciation for the rare encounters. Space between worlds is as important as the worlds themselves. Every asteroid you encounter is 4.6 billion years old. Formed when the solar system formed. Witnessed the sun's entire history. Predates Earth's oceans. Predates Earth's atmosphere. Predates life. These are the solar system's elders. Not wise, perhaps, but old beyond human comprehension. Floating among them, you're in the presence of deep time, surrounded by witnesses to planetary formation, stones that remember what we can only imagine. Amy Simon, a planetary scientist at NASA, said, "Asteroids are like books in an ancient library that never burn down. Each preserves a different chapter of solar system history. Some are water-rich, some bone-dry. Some are metallic cores of shattered worlds. Some are chemically primitive. Reading them requires patience. Spectroscopy, orbital analysis, sample return missions, decades of study. But knowledge accumulates. We understand planetary formation better now than ever, thanks to these patient stones. Thanks to the ancient library floating in darkness. For every asteroid catalogued and studied, thousands remain unknown. For every kilometer-sized asteroid, millions of smaller fragments exist. The belt extends beyond our observations into statistical invisibility. Most asteroids will never be named, never visited, never studied. they'll orbit the Sun for billions more years in peaceful anonymity. There's humility in recognizing the limits of knowledge. The asteroid belt is too vast, too numerous for complete understanding. We'll always be sampling, never comprehending the entirety. And that's beautiful. Mystery remaining, wonder preserved. Breathe with the orbital periods. Slow and deep. Inhale the vastness. Hold the ancient silence. Exhale into timelessness. The asteroids drift. You drift. Everything in the solar system drifts in orbits determined billions of years ago. Predictable, mathematical, peaceful. Ceres completes one orbit every 4.6 Earth years. Slower than Mars, faster than Jupiter. Between inner solar system's rush and outer system's patient crawl, the asteroid belt occupies the middle distance. Transition zone. Not here, not there. Between. If you could float here for years, protected and supplied, you might drift for months, seeing nothing but distant stars. Occasional asteroids appearing and receding. Loneliness or peace depends on perspective. Either way, quiet. Complete quiet. The total mass of the asteroid belt is only 3 to 4% of the Moon's mass. Gathered together, barely a small world. Scattered across billions of cubic kilometers, an entire region. Distribution matters. Spacing creates experience. Emptiness defines the belt as much as the stones do. These rocks remember the solar system's youth. Violent collisions, failed planet formation, Jupiter's disrupting influence. They carry that history silently through orbit after orbit, millions of years at a time, asking nothing, preserving everything. Some asteroids are pristine, chemically unchanged since formation. Others were heated, differentiated, then shattered. Each stone tells a different story. Each story teaches something about how worlds form, how chemistry organizes, how gravity builds, how collisions destroy and create. The asteroid belt isn't a failed planet. It's a preserved snapshot of planet formation. This is what the inner solar system looked like 4.6 billion years ago. Countless small bodies colliding, accreting, building. But here, Jupiter intervened, prevented completion, left the raw materials scattered, ancient construction site abandoned. We approach Pallas now, the third largest asteroid, 512 kilometers in diameter. Its orbit is tilted 34.8 degrees to the ecliptic, highly inclined compared to most asteroids, suggests a violent past. Some catastrophic event changed its orbital plane. Pallas tumbles through space at an angle, forever tilted, forever different. Hygeia drifts in the distance, the fourth largest asteroid, 434 kilometers across. It's the darkest of the major asteroids. C-type, carbonaceous, chemically primitive, nearly spherical, may qualify as a dwarf planet, waiting for detailed study. Another world with stories to tell. Patient, ancient, quiet. Surface temperatures here range from -73 degrees Celsius in the inner belt to -108 degrees in the outer belt. Cold, but not as extreme as the outer solar system. No atmosphere to trap or distribute heat. Only direct sunlight or shadow. Temperature swings from illuminated side to dark side, but slow swings. Asteroids rotate slowly enough that thermal equilibrium is gradual. No sudden shocks, just gentle cooling, gentle warming. Throughout the belt, countless smaller asteroids tumble unseen. Boulder-sized, car-sized, house-sized. Too small to detect from Earth, too numerous to catalogue. Each one ancient. Each one with its own rotation, its own orbit, its own history. The belt contains complexity beyond measure. Endless variation, infinite stories. Most will never be told. The dust between asteroids comes from collisions. 2 asteroids impact. Chips fly off. Those chips collide with others, creating smaller chips. Eventually, dust. Sunlight pressure pushes the dust inward toward the sun, or outward toward interstellar space. The belt slowly loses mass, grinding itself down over billions of years. But the process is so slow, so patient. The belt will exist for billions more years before noticeably depleting. Some asteroid fragments reach Earth as meteorites, providing direct samples of space for study. The oldest dated meteorites are 4.568 billion years old, age of the solar system itself. When you hold a meteorite, you're holding material older than Earth, predating the planets. Ancient stones fallen to a younger world. Messages from deep time. Breathing deeply now. Inhale the silence. Hold the peace. Exhale into timelessness. Your body releases. Your mind quiets. Floating among ancient stones, safe in the vastness. Nothing to fear, nothing to do. Just peaceful drift. The belt is three-dimensional. Asteroids orbit with inclinations up to 20 or 30 degrees. Not a flat disk, but a volume. Some asteroids pass above the general plane, some below, adding to the emptiness, spreading out the population. More space, more silence, more peace. Jupiter's gravity still influences the belt today, slowly perturbing orbits. Over millions of years, some asteroids drift into the inner solar system, becoming near-Earth asteroids. Others drift outward. The belt's population slowly evolves, depleting, but so slowly, billions of years remaining. The stones will outlast humanity, outlast Earth's oceans, patient witnesses to whatever comes. We've been drifting for hours now, encountering worlds, learning stories, floating through history. And now the encounters grow rare. More emptiness, more silence, just as it should be. The belt teaching its final lesson. Appreciation of space, beauty of absence, peace in the void. If you walked on an asteroid's surface, gravity would be barely perceptible. A 10-kilometer asteroid might have surface gravity 1/10,000th of Earth's. You could jump and escape entirely. One push and you'd drift away into space. But gently, so gently, taking hours to realize you're no longer bound. The asteroid releasing you, letting you go into the greater emptiness. The asteroids ask nothing of you. They simply exist, orbiting, tumbling, aging, remembering, waiting. They were here billions of years before you. They'll be here billions of years after. Your brief consciousness drifting among them is a momentary gift. Appreciation without possession. Observation without disruption. Peace without effort. Somewhere in this belt, an asteroid rotates with your name on it. Metaphorically speaking. Thousands of asteroids are named for people. Scientists, artists, musicians, teachers. Small honor for a human life. Permanent marker in the solar system. Long after the person is gone, the asteroid continues. Name attached to ancient stone, continuing its orbit. Patient, timeless. The belt is a transition zone between the terrestrial planets and the gas giants. between warmth and cold, between rocky worlds and icy worlds. Inner belt asteroids are rocky, outer belt asteroids more water-rich. A gradient of composition, temperature history written in chemistry. The solar system's complexity preserved in distribution. No human has ever visited the asteroid belt in person. All our knowledge comes from telescopes and robotic spacecraft. But someday, perhaps, human explorers drifting as we drift now, observing directly, walking on surfaces untouched, looking out from asteroid horizons, seeing the belt from within. That day will come. The asteroids will wait. They're very good at waiting. Your breathing has slowed, matching the patience of stones. Inhale, hold, exhale. Each breath deeper into rest, each moment quieter. The asteroids drift. You drift. Separation dissolving, becoming part of the emptiness, part of the silence, part of the ancient peace. The sun appears smaller from here, about half the size it appears from Earth. Still bright enough to illuminate, but dimmer, casting longer shadows, creating starker contrasts. The asteroids float in harsher light, no atmosphere to soften. Pure illumination and pure shadow. Clean geometry, simple beauty. Orbital mechanics are pure mathematics. Every asteroid follows Kepler's laws precisely. Elliptical orbits, predictable periods, constant angular momentum. The universe following equations. Physics as reliable as breath, as certain as rest. Mathematical peace. The belt contains iron enough to build 1 billion cities, water enough to fill 1,000 oceans, resources beyond measure, but also beauty beyond price, ancient history beyond valuation, scientific knowledge beyond economics. The asteroids are treasures, not for taking, but for appreciating. Wealth measured in understanding, richness measured in wonder. We near the end of our journey, but the belt has no end. It continues beyond our passage. Billions of stones in their orbits, continuing their ancient dance, indifferent to observers, perfect in their existence, needing nothing, offering everything. Lessons in patience, teachers of time, keepers of memory. The asteroid belt is mostly empty space, and that emptiness is perfect. No rush, no collision course, just gentle drift through vastness, occasionally encountering worlds older than Earth, mostly surrounded by silence. Peace in the spaces, rest in the emptiness, sleep in the ancient dark. If you could float here indefinitely, you might drift for years, seeing nothing but stars and rare stones. Not loneliness, solitude. Not emptiness, spaciousness. Not danger, safety. The belt is peaceful, has always been peaceful, will always be peaceful. Hollywood lied. The truth is better. These rocks remember the solar system's youth, violent collisions, planetary formation, Jupiter's disruption. They carry that history through orbit after orbit, year after year, million years at a time, asking nothing, preserving everything. Patient witnesses, ancient keepers, silent teachers. Ceres makes one orbit every 4.6 years. Between rush and crawl, between inner and outer, middle distance, transition zone, balanced, patient, steady, like breathing, like rest, like sleep. We drift now among the ancient stones, surrendering to the vastness, breathing slower, thoughts quieter, body heavier, mind lighter, everything settling, everything releasing into the silence, into the peace, into rest. The asteroids keep watch, as they have for billions of years, as they will for billions more. Patient, ancient, peaceful, eternal. And you rest among them, safe, quiet, drifting, sleeping. $4.6 billion years old. Ancient stones, peaceful darkness, infinite patience. The belt continues, forever orbiting. timeless silence. You rest now. Floating among worlds. Nothing to fear. Only peace. Only rest. The emptiness holds you gently, safely. Sleep now. Asteroids drifting. You drifting. Ancient silence. Perfect peace. No rush, no danger, only vastness, only rest. The stones remember. 4.6 billion years. You sleep. They watch. Breathing with orbits. Slow. Deep. Peaceful. Emptiness is beautiful. Silence is perfect. Rest is complete. between Mars and Jupiter, between worlds, between thoughts. Sleep. Ancient river of worlds, flowing silently forever. Rest now. The belt keeps watch. Patient stones, timeless guardians. You sleep. Drifting peacefully, breathing quietly, resting completely. Sleep. .6 billion years. Ancient, eternal, peaceful. The asteroids continue. You rest. Perfect balance. Sleep now. Vastness surrounds you. Gently, safely, forever. Floating among elders, ancient stones, peaceful witness, rest. Sleep in the silence. Sleep in the emptiness. Sleep in peace. Between worlds, between thoughts. Rest. Drift. Sleep. Ancient stones drifting. Peaceful emptiness. Safe darkness. Rest now. The belt remembers. Patient, eternal. You sleep. floating gently, breathing slowly, resting deeply. Peace. Four billion years of silence, waiting, watching, sleep. The asteroids orbit forever, timeless, rest. Darkness holds you gently, safely. Sleep now. Between Mars, between Jupiter, between dreams, rest. Ancient river flowing silently, eternally. Peace. Ceres watches. Vesta watches. You sleep. They drift. Emptiness embraces. Silence comforts. Rest completes. Sleep. The belt continues. Patient stones. Ancient peace. floating among worlds, drifting through time, resting in space. Timeless, peaceful, eternal. Rest. Ancient stones, silent witness, patient guard. Sleep. vastness, whole.